Next, let's get into data manipulation instructions. And so hardwire relay operations, time delay circuits, these are things that you would find that you would want to be doing. And here is the equivalent programmed in a PLC time delay circuit. And so you can pause the video and look over this, but we're seeing these various implementations with the PLC approach. Here's a timer program implementation using the EQU instruction. So this might be an example as you do some practice programming to see how that looks. Here's a counter program that implements using the LES instruction. And so here you can spend more time focusing on that. And so for a vessel filling operation, the receiving vessel has its weight monitored continuously by the PLC program as it fills. When the weight reaches a preset value, the flow is cut off. Should the system leak additional material into the vessel, the total weight of the material could rise above the preset value, causing an unequal instruction. If used to go false and the vessel to overfill. So there are some things here that can be useful for an industrial application when you have an assembly line and maybe finding things that fall out a certain level, and you would reject that for it to continue processing. What about numerical data I/O transfers? And so multi-bit interfaces allow a group of bits to be input or output as a unit. Each one of the switches provide 4 binary digits at its output that correspond to the decimal number selected on the switch. The BCD input module allows the processor to accept a 4-digit digital code and input their data into the specified registers or word locations. Remember, binary coded decimal, there's 4 lines, and so this is what we're doing for having the input for those. The 7-segment LED display is a typical binary coded decimal output device. It displays a decimal number that corresponds to the BCD value it receives at its input. The BCD output module is used to output data from a specified register or word location. For monitoring the setting of a thumb wheel switch, this is what the circuitry would look like, and you have the output there that you can make sure that things are working properly. For analog modules, you can have a conversion where the analog signal is transitioned to a 16-bit digital signal input, or a 16-bit digital signal is translated to an analog output. So you either have an analog to digital conversion or a digital to analog conversion. An analog I/O will allow monitoring and control of analog voltages and currents. The analog output interface module receives numerical data from the processor. These data are then translated into a proportional voltage or current to control an analog field device. Next, talking about closed loop control. In open loop control, no feedback loop is employed, and the system variations which cause the output to deviate from the desired values are not detected or corrected. On the other hand, a closed loop system utilizes feedback to measure the actual system operating parameters being controlled, which is a very useful feature. Here's just a little bit of a perspective on a PLC closed loop control system. Adjustments are made continuously by the PLC until the difference between the desired and actual input is as small as is practical. So that's what you want to try and do. That gives you the closed loop controlling. With on/off PLC control, the output is either on or off. For proportional controls, they're designed to eliminate the hunting or cycling associated with on/off control. Proportional control allows the control element to take an intermediate positions between an on and off. So the PLC analog output module controls the amount of fluid flow by adjusting the percentage of valve opening. For proportional integrated derivative, PID control is the most sophisticated and widely used type of processor control. PID controllers produce outputs that depend on the magnitude, duration, and rate of change of the system error signal. One operating information from the machine is called the process variable or feedback. The input from the operator that tells the controller the desired operating point is called the set point. The difference between the set point and the processor variable is called the error. So in terms of programming controllers with PIC, programmable controllers are either equipped with PID IO modules that produce PID control or have sufficient mathematical functions of their own to allow PID control to be carried out. All right, well, that's ended for this chapter. Thank you very much.